You might have heard of binomial expression like a plus b raised to the power of 2 or a plus b raised to the power of 3 in your school days. To calculate a plus b raised to the power of 2, we can use the formula a square b square plus 2ab. To calculate a plus b raised to the power of 3, we can use the formula a cube plus 3 a square b plus 3ab square plus b cube. But what if we want to calculate a plus b raised to the power of 4 or 10 or any other number? This is where the binomial theorem comes in. The binomial theorem is a fundamental concept in mathematics that allows us to expand binomial expressions like a plus b raised to the power of n, where n is a positive integer. It was first formulated by a 10th century Persian mathematician named Al-Karaji and later popularized by the French mathematician Blaise Pascal in the 17th century with his famous Pascal's triangle. The binomial theorem states that the expansion of a plus b raised to the power of n is given by the sum of n plus 1 terms, where each term is of the form choose k times a raised to the power of n minus k times b raised to the power of k, where n is a positive integer. K is an integer ranging from 0 to n. A is the first term in the binomial expression, b is the second term in the binomial expression, and choose k is the binomial coefficient which we discussed in the previous video. Recall that it is the number of ways to choose k elements from a set of n elements and is given by the formula n factorial divided by k factorial times n minus k factorial. Let's take an example. If we substitute 2 in A and 3 in B with raised to the power of 4 for n, we get 2 raised to the power of 4 plus 4 times 2 cubed times 3 plus 6 times 2 square times 3 square plus 4 times 2 times 3 cubed plus 3 raised to the power of 4, which after further simplification comes out to 625. But you might be thinking by now, how is binomial theorem useful in probability? Well, the binomial theorem can be used to calculate probabilities in scenarios where events have binary outcomes, such as success or failure, heads or tails, or happy or sad. Here's an example that illustrates the use of the binomial theorem in probability. Suppose you toss a fair coin 5 times. You want to find the probability of getting exactly 3 heads. Since each toss has 2 possible outcomes, heads or tails. This is a classic example of a binomial experiment. Using the binomial theorem, we need to figure out the values of n, k, a, and b for our problem. In this case, n will be 5 since we have 5 coin tosses. K would be 3 because we want to find the probability of getting exactly 3 heads. A would equals 0.5 because probability of getting head is half, and similarly b would equals half as well. Notice here that the k term in this case is fixed since we are looking for exact 3 heads and not a range as in the binomial theorem, so we can remove the summation notation from the equation. Also, since we are calculating the probability, we can replace the left side of equation with p of k to represent the probability of getting k heads. Substituting these values in the equation, we get 5. Choose 3 times 0.5 raised to the power of 3 times 0.5 raised to the power of 2, which is equal to 0.3125. This concludes our discussion on the binomial theorem and its applications in probability. I hope you found this video helpful, and now that we have seen more ways to count outcomes, in the next video we will look at a more complete definition of probability that applies to all types of experiments. Thank you for watching.